All right, y'all. This is the third time I'm trying this. It's crashed the last two times, so hopefully it won't crash again. Oh my goodness. All right, so this is the continuous game examples. Okay, how to solve them, how to find the Nash equilibrium if you're like competing or colluding. Um, and we're going to use the same examples used in class because I hope that the math, and I'm recording this before we did that class, but I'm hoping the math turns out to show that we figured it out. That you guys work together, kind of figure out how to get the best outcome for you. Okay, um, so just a refresher. This is the gourmet burger one, right? We had burgers sold, b equals 44 minus 2x plus y, right? And the profit was, the cost was 8. So how do you get profit? So again, here's the demand curve for x, demand curve for y, right? You'll notice they're symmetric. So that actually is going to save us a lot of time on this problem, right? Because it means we can do x and y and then just like, or we can just do x and say that y is basically the same, okay? So profit x is going to be qx times px minus cx, right? This is how many you sold times the profit on each of them. And if we calculate that out, right, that's 44 minus 2x. And I'm just going to use x and y instead of writing px and py every time from this point on, plus y times x minus 8. All right, I expand this out, and I get that it is 44x minus 2x squared plus x times y, and then minus 352 plus 16x minus 8y. Now I'm going to group this, rearrange it so I have all of the x squareds and all of the x terms and then all the non-other terms, okay? So I have negative 2x squared, then I have 44 plus 16, that's 60. Then I also have a y times x, so I have 60 plus y all times x. That's minus 352 minus 8y. All right, so if you're in calculus, you've figured this out, but there's actually a really simple way to do this. Anytime you have an equation like this, you can find the x max. Actually, let me erase that. If it's of the form negative ax squared plus bx plus c, the x max, then x max, or the best x, is when, right, you have b over 2a. Okay? So in this case, and we want to maximize, right? This whole idea of best response is you want to maximize your outcome, right? So we definitely want the owner of X restaurant is going to try and find X max. So I get X is equal to, right, this is B is 2, B is 60 plus Y over 2A. A is 2, so this is over 4. And that's equal to, and then we have that, and we would also, by the way, know that Y then is equal to 60 plus X over 4. Now, it turns out we don't need that, but that's what you do. You do this for both of them. That's the goal. Okay. Now, in this case, we don't need to, because we can also assume because X and Y are symmetric, we can assume X equals Y. Whatever I'm doing that's best for X is also the same thing as what you do best for Y. So I get X equals 60 plus X over 4, which leads to X equals 20. Okay, and then Y equals 20. Again, they're symmetric. I can also find the profit of X. So the profit of X, right, remember it's the quantity of X, which is 44 minus 2 times 20 plus 20 all times, right, 20 minus 8. This comes out to be $288. And that means profit of Y is also $288. Okay, so I'm going to be smart enough, I'm going to save this before I go to the next part. So it doesn't, if it crashes again, I don't have to start from the very beginning. Whew. Okay, now this is the outcome. This is the equilibrium, 20/20 each. The profit's 288, 288. What if they collude? What if they work together? What if the two restaurant owners say to each other, hey, we're not out just out for ourselves, we're out let's work together, let's collude. Let's do what's best for both of us. Okay. So I'm going to go ahead and copy this piece from here. This is still true. I gotta get rid of that little right there. So this is profit x equals that. And we can assume that profit y, right, is equal to 44y minus 2y squared plus xy minus 352 plus 16y minus 8x, right? It's just the flip. Again, symmetric, right? We add those two together. Negative 2x squared minus 2y squared, right? Plus 2xy. We have 44 plus 16 minus 8, so plus 52x. We have 44y plus 16y minus 8y plus 52y. And we have this big constant, right, the negative 704. Now, again, symmetric. So if we're doing the best for both of them, right, we're going to assume, because of symmetry, that x equals y. And we're going to get then that this is negative 2x squared plus 104x minus 704. Again, notice this is of the form, right? This is negative ax squared plus bx minus 704, or minus c, or plus c. Right? So, again, we get the max at x max at 104 over 4, right? 2a, which is 4. And this is at $26. Okay, so x equals y equals 26. Now, we can again figure out the profit, right? The profit the same way. It's going to be 44 minus 2 times 26. Actually, when I do it, that would be the profit for one of them, and you could double it. But let's go back and let's look at this result right here, this negative 2 times 26 squared plus 104, 26 minus 704. Right, that's our profit total. And I guess I should have written that up here. Equals profit total. Okay, that's that. And this comes out to be, I actually didn't calculate this out. So let's go to Wolfram here. 2 times 26 squared plus 104 times 26 minus 704, 648. Or 324 each, right? So that's a gain over the 288 each. It's not a huge gain, but it's like a at least a 10% gain, right? This is, or they're just more than competing. Okay, so it's over 10% more just by working together instead of competing with each other. Okay. All right. All right, so now let's look at a little more complicated example where the people are against each other a little more. This time, right, this is the second one. This is where you have McDonald's and Shake Shack, okay? And McDonald's, right, they have a little bit more of what's called price elastic, right? If you change the X price, it changes your quantity by a lot. Shake Shack's a little bit more resilient, but Shake Shack's stuff also costs more than McDonald's. Burgers also cost more. So we can do the same thing. Still got this setup here, okay? We're still going to find out that the profit for McDonald's is equal to 150 minus 30m plus 2 times s. I'm actually going to use h for Shake Shack because s's look like 5s, and I don't want to get confused. So h for Shake Shack, okay? Times, right, for McDonald's, it's m minus 1. And at the same time, we can go over here and say that for Shake Shack, right, it's going to be 75 minus 6 h plus 4m, all quantity times h minus 3. Okay, we got to multiply this out again. 150 m plus or minus 30m squared, okay, plus 2hm minus 150 plus 30m minus 2h u. Okay. Equals, we can again consolidate this to get in the form of what we want, 30m squared, right? Plus we've got 150, or actually 180, right? We've got 180m, 30m and 150m, so 180m. No, actually I don't want 180, right? I want 180 plus 2h all times m minus 150 minus 2h. And again, we have that form, right, of negative a m squared in this case plus b times m plus c, which means my max at my x, well, my m, not my x in this case, my m is going to occur, my m max, at 180 plus 2h over 60. Okay. Now I can't assume that h and m are the same, so I can't quite do that this time. So I have to go now to the other side here. This is going to come out to be 75h minus 6h squared plus 4mh minus 225 plus 18h minus 12m. Okay, again, rearrange, same idea. Okay, I've got negative 6h squared, okay, plus 75 plus 18, that's 93, plus 93 plus 4m, all times quantity h, minus 225 minus 12m. Again, we have negative ah squared plus bh plus c. So my h max is going to be when I have 93 plus 4m over 12. Two equations, two unknowns. It's really not that bad, actually. Okay. Here I can solve this. I have, now this becomes 60m equals 180 plus 2h, which means that h equals 30m minus 90. Plug it in right over here. 30m minus 90 equals 93 plus 4m over 12. If you solve this, you get that m 3.29. Oops. And h equals 8.7. And if you go back and you plug into the profit equations, you're going to end up with profit for m 159 or so, 158.7, and profit for h equals 205. So Shake Shack should have done a little bit better on average, and I think that's what we saw. I hope that's what we saw when we did it. Okay. All right. So again, what if they collude instead? I'm going to save. I'm getting smarter every day. What if they collude? And again, let me go ahead and cut this. This is the profit for Shake Shack, and actually here, and this right here my tilted but hopefully still legible option. Ha. All right, let me I can actually fix this a little bit. All right, I'm going to slide that up. Pretend it says the same. Pretend it's on the same line. All right. So what I've got now is I've got my profit of H, profit of M, and I have collusion, which means I want profit total. I want to maximize my total profit. Okay. So I'm going to do my negative 6h squared minus 30m squared Okay, I'll do the MHs, so plus 6MH. All my H's, 75 plus 18 minus 2, so that's plus 91H, plus 150 plus 30 minus 12, that should be 168M. And then I've got just the numbers, right? So this is minus 375. Okay. Now, this one you can't do as easily. Okay. So we're going to use Wolfram Alpha. Okay. Wolfram Alpha is a beautiful thing. Okay. And I'm just going to type it in here. I'm going to type maximize. And I'm going to type in that equation. Negative 6h squared minus 30m squared plus 6m times h plus 91h plus 168m minus 375. If I typed everything in right, we should get some numbers. That's not what I got last time. So what did I mess up? So sometimes it gets a little finicky. So I should probably put some times in there. Maximize. You know what it might be? Sometimes it doesn't like it if you do variables that aren't x and y. So I'm going to try it. X and y. X, y, x, y. So remember that x is h and y is m. There we go. So we get that to max profit, we get that we want y we want h to equal 9.46 and x to equal 3.75. Okay, and together they're going to give you a profit of 370 basically. Which if you look back, 370 is just, it's actually not that much more in this case, right? Together these gave a profit of 364. So really, like, this is not actually much different. This is a case where colluding actually does not give you a huge benefit over competing. Okay. All right. Save it. All right, one more time. This is the working together one, right? This is the baker and cheesemaker, right? And you can see the big difference here, right? It's the demand curve. This is on 50 minus 30 plus 2y, right? So if the other person's prices go up, your sales go up. Here, minus 30 minus 10. So the other person's price go up, your sales go down. So these already have a little bit of a they're not really competitors as much. They're kind of working together, but they're still a little bit. They're still trying to do what's best for them. So work through it again. Profit B, right, is going to be QB times the price minus the cost, right? This is QB minus or times price of B minus cost of B, right? This is 200 minus 30B minus 10C times B minus 1, right? And for, right, the same thing, price of C is quantity C times price of C minus cost of C. Okay. So when we do this, right, we get the, this is, right, oh, this has got to be in parentheses. My bad. This is 100 minus 5C minus 5B all times C minus 4. So let's expand, right? Got to do that. 200B minus 30B squared minus 10BC minus 200 plus 30B plus plus 10c. And again, we want to group these by the b term. So this is minus 30 b squared plus 200, 230 minus 10c, all times b, minus 200 plus 10c. Again, it is of the ab squared plus b times b. Well, right, so we end up getting that b max is equal to 230 minus 10c all over 60. Same thing over here, we get 100c minus 5c squared minus 5bc minus 400 plus 20c plus 20b. Negative 5c squared plus 120 minus 5b, all times quantity c, minus 400 plus 20b. That means c is equal to 120 minus 5b over 10. All right. Now you might think this is ugly, but it's actually not. It's actually kind of nice. There's something nice about this, which is that 10c, we can simplify this 10c equals 120 minus 5b, and we can plug that directly over here. So this becomes 60b equals 230 times, nope, not times, minus 10 times 120 minus 5b. Divide out by 10, I've got 6b equals 23 minus 120 plus 5b. Is that right? Uh-oh, I did that wrong. There needs to be a 10 there, right? Because I'm literally putting 10c into 10c. Knew I did something wrong. So this is then 60b equals 230 minus 120 plus 5b, or 55b equals 110, b equals 2, and then you can figure out that c equals 11. Nice numbers for a weird, these random numbers come out to whole numbers is kind of cool. I don't know, I think it's kind of cool. We can do the profit for b. Turns out if we plug it back in, right, we've got 200 minus 60 minus 110 all times 1, and that comes out to be 30. And over here we've got profit of c is equal to 100 minus 55 minus 10 all times 7, and this comes out to be 245. So you can see the cheese maker makes a lot more cash than the bread maker. All right. So select. Same deal. Now we're colluding. Nope. Somehow I screwed that up. C. There we go. So again, if I want profit total, I've got profit B, profit C, so profit total equals negative 30b squared minus 5c squared minus 15bc plus all of my b terms, 230 plus 20 plus 250 b all my C terms, negative 10C, is it 10? Hope that's a 10. 10 plus 100 plus 20, so that's 1 plus 130 C. All my BC terms, I read my BC terms, and then I numbers, which is minus 200, minus 400, minus 600. Okay. All right, and again, we're going to plug this into Wolfram Alpha because I'm not sure we can do it other ways. So I'm going to try B and C again. I think that should work. Minus 30 times B squared minus 5 times C squared minus 15 times B times C plus 250 times B plus 130 times C minus 600. Let's maximize that. There we go. So it worked with it this time. We get that B equals 1.47 and C equals 10.8. Okay. So you'll notice those are actually pretty, for C it's basically the same price. For B it's much lower. B is, instead of making a profit of $1 a loaf, is making 47 cents a loaf. C has gone from $7 to 6.8. And the total profit, right, according to the calculator here, is 285.3. That's actually not that much different from what it was before. Before it was 275. You can get examples. I mean, these numbers I played around to try and make the in-game clean class games fun. It wasn't to like make these calculations that interesting. But you can actually end up with interesting situations where you can get a lot of more by colluding than competing. The other interesting thing you can end up with is you can end up with a B, like one of these two values where they're actually losing money, just because it makes the other one gain money. And there are actual real-life examples of that. If you guys don't know this, PlayStation, Xbox game consoles, they oftentimes sell those at a loss. Because if more people buy that, more people buy games. And they can make profit on games. So if they figured out that you can make a profit on the games by selling everything else by selling the consoles at a loss. That's what they do. Okay. Hopefully these examples are enough to sort of follow along and sort of like get the rhythm of solving this. Your problem set is basically going to be like problems similar to this. So yeah. All right. Have a good one.